Unit 9.7, Object Superclass. Let's dig in. Last unit. So, the Object Superclass is at the very top. Let's check that out. Always at the top. There is no one above it. So, because there's no one above it, it's the first to be made. Always. Doesn't matter what you're making, the object is made first. But something else is important. What's in that class? And for that, we'll search it. Okay. So, it says a blueprint. We all know what this is, methods and attributes. This is actually the data. By the way, it's attributes, it's instance variables, it's properties. There are a lot of words for these. Fields, all mean the same thing. But let's go to the object class itself. At the very top, here's the API. It has a number of methods. You know what the methods are? Ready? Equals. ToString. Those are the two that the AP exam requires. What does it mean? Every object has a string representation. This is why strings are so important. The string data type is most important because every single object must be able to be turned into a string. So it returns a string. Yeah, that includes everybody. So if you have a button, a label, doesn't matter what it is, there's a string for it. Now, obviously, when the button returns its string, it's going to tell you its size, its bounds, like where it is, how big it is, and all the information about it. I'm going to show you how to do that in our API. The other one is equals. Equals is a method that compares two objects and determine whether they're the same. Now, what do I need to do? Override them. I need to override them. The way to override them is to implement them. So let's do this. So I'm going to override the ToString first. At the very end, everybody is going to get it. It's polymorphic. So I'm going to override it here. Public string ToString. Overriding. Signature exactly the same. No parameter. Returns a string. Okay. So what am I going to do? Well, I need to return information about whatever I'm in. I'm in the mail right now. So I'm going to say the to address, the from address, and the weight. I'm going to calculate the insurance. And I'm going to calculate the postage. And I'm going to calculate the total. So let's see. Got it. No, this is when you want to make it look nice. So I'm just going to, let's do this. Return weight. Okay. And get weight. So I got the weight part. So I got to get all the information. So to address, from address. Oh, wait a minute. We didn't do any getters and setters for this. Haha. Need some. Let me put them right here. Do you remember how? How do I get my getters and setters? Source. Look for them. Look for them. Get set. All right. I want to address, from address, and to address, and weight. Okay. Obviously, I could have typed them up too, but yeah. I got all of my get sets. And these are all inherited. So I'm going to call them down here. All right, so I'm going to put I'm pretty much just going to put a \n, drop to a new line. And I'm going to make another one. This one is the to address. You know what I'm going to do? I'm going to drop them down. Okay. So to address. How about this? That to address. Or how about this? This, that, get me the to address. I'm going to drop down. You should be able to do this. You should see what I'm doing here. And then I'm going to from address. This, that, get me from address. Drop down. I'm putting all the information about a mail. That's what that means. Some languages call this the description. All right, so I got the weight. I got the, I should have put this here as well. Even if you don't write it, it's there. This, that, get me the weight, the to address, the from address, to address. Okay, I need the insurance. Let me do the postage. This, that, calculate the postage. I'm doing everything. I want to do the insurance. This, that, calculate some insurance. Drop down. Everything on a new line. I got the insurance, I got the postage, and I want the total. It's going to be a little bit fake here because I'm going to pretend everybody has, who can do it, has extra insurance. So this, that, calculate the total. I'm going to make it true. So I just override the toString for object. So the question then is, what would object's toString look like? What would it look like if I were to do this without overriding it? So we're going to check that out as well. So let me go ahead to the main. And what I'm going to do in the main is very simple. I'm going to first show an issue. Polymorphism is great, but you call polymorphic methods. If you're calling a method that's not polymorphic, we have a problem. Here we go. Kids can do what parents can do, but parents cannot do what kids can do. How do I know that? Here's how it works. See these guys over here? They both can do the insurance that takes in a Boolean that says, hey, you have extra insurance. This is the extra insurance. Remember that extra insurance only happened over here. These guys can't do it. None of them. This can't do it. This can't do it. This, or this, right? Only these two guys can do the extra insurance. So, because that's true, I cannot call it unless I'm sure that this is actually one of these two. You may say to yourself, wait a minute, but it is. It's a priority box. Yeah, but it's masquerading as a male. See, I'm trying to take advantage of polymorphism. Whenever you see these two things not being the same and they're correct, meaning this is a this, if it's written correctly, you're trying to take advantage of polymorphism. So that means you want to call a method that everybody does. The fact that I'm calling a method that only this one does, this gives me an error. A little tricky. It is a box, but at the same time, it's masquerading as a male. So it can only do things that everybody does. So since it's specifically calling this because only this and the envelope for priority does it, the box and the envelope for priority, I can't call it this way. The only way I can do this is I need to cast it. So no, you got to be careful here. If you're going to cast the and then call. Let me put parentheses, a lot of parentheses here. I could have done it outside of the print, but it's fine. So right now, what I did is I turned the M4 into a private box because it is. And then I call it. What if it was not actually a private box? It would crash. It would be a class cast exception, meaning I'm trying to cast it to something that it's not. You won't see the error here. It only happens when it runs. But because I know it is, I can cast it to it. So I should really be doing this. Remember me showing you this? Remember? Let that one sink in. See, I should be saying, if it actually is a box, then cast it to the box and then do it. That's what I did here. That's why I showed you that. Now, if you see a question starting off like this, and then it calls a method, your first question is that method polymorphic? Because if it's not, we have a problem. Calculate postage is fine. Calculate total is fine. These are all polymorphic. Calculate insurance, actually this one is at the very top. It's not necessarily polymorphic because we all do it the same way. It's just done once and everybody inherits it. That's another way you can tell if it's a method that everybody does, whether it's polymorphic, meaning it's overridden many times, people are doing it differently, whether that happens or it's at the very top. This is perfectly fine. This type of instantiation where the two things don't match. The guy on the left should be priority box, M4 equals new priority box. If I did that, if I did priority box like that, what's going to happen here is now this don't need this cast. See? And you may sit there and say, wait a minute, how come it didn't affect these? Because it is a male. A priority box is a male, so it could definitely go in an array of males. But it won't be able, we won't need to do that. Now, you may start getting tricky and say, well, when do you do this, when you don't? Well, if you're going to do polymorphism, if you're going to do it, do it. And if you're not going to do it, don't. So if you're going to do polymorphism, we want them all to be the same type. All males. Doesn't matter what type. When we call the calculate postage, it does it right. Okay. So, side little thing. Sometimes the APA exam has this question on there. So that's a little tricky one. Now, let me go ahead and check out the overridden method now. ToString, right? Watch this. I'm going to print that same M4. All right, a couple of things here. So I'm going to put a little note here. So we're talking about the object ToString. Realize that I just print the actual object itself, the instance, right? I made a M4, it's a male, and I print it. You know what this means? This is the same thing. One thing with computers, it has a lot of does things for you. So for example, if I don't make a class public, like if I take the word public off, it is public. If I take the public off the method, it is public. So if I don't put the ToString on when I print an object, it is there. So whenever you see a method printing the instance, it's calling the ToString. So let me drive this point home. These two things are exactly the same. It's kind of like me saying, should I write the this or not? If I take the this off, it's still there. Doesn't matter if I put it or not, it's there. So in the case over here, if you put an object in here, the actual object, mind you, instantiate either M1, M2, M3, or M4, it's going to print its ToString. Watch this. Boom. See it? Actually, let me show you it properly. See right here? There you go. Printed it twice. Oh, I printed it twice because I did have it twice. I have it here and here to show. Actually, I'm going to put a little space in between. And again, print ln without anything says put a space. All right, so right there, twice. Boom, boom. Point is, if you have a toString, if you override the toString from the object, everybody has it. Watch this. M3, it has it too. Oh, how do you know everybody has it? It's at the very top. So it's inherited right here. I'm going to add one more piece to this toString, and then we go to equals. I'm going to override the equal as well right beneath here, and we're going to do two males are equal if their weights are the same. Once their weights are the same, they're equal. So we got to do two things. They have to be boxes and the same weight, or envelopes and the same weight. That's what equal is going to mean for us. So right now I'm going to override it. So if I go down here and I wanted to override my toString, copy it. Watch what I'm going to do. I'm going to partially override. So I'm going to say, hold on a second. Let me just check something out. I'm going to add one more piece. So I'm going to say the weight and so on. And I'm going to say the type as well. So let's put something else here. I'm going to say male. Why am I doing that? I'm putting the type. So I'm saying it's a male. Okay. You know, let me put the type at the bottom. I'm doing that for a particular reason. Let me put it at the bottom because I wanted to see how this thing propagates down. So let me drop this down. And let me say type. Say I am a male. Okay. Now I'm going to go down to the regular male. And for the toString, I'm going to say return. Oops. Return super dot toString plus I am a regular male. Okay. Now I'm going to do it all the way down. So copy. I'm propagating it all the way through. I am a regular envelope. Then we go down here. I'm going all the way down the API. I am a regular box. I am a priority mail. I am a priority envelope. And then, last but not least, I am a priority box. Now the question is, what would that do when I run this? Okay. So let me go ahead and just nice these up a little bit. Make them look a little better than this type. Okay. Let me save all. Now, actually, let me get rid of it. I don't need this. I can stay right there. Main. See M3. Watch this. This is where I want to make sure we see. Okay, so I should have been dropping them down. I'll leave in a space. I am a male. I am a regular male. I am a regular envelope. What this does show is the order of the construction. Let me leave a space. I think that might be better. Or maybe a new line. I'm gonna make a new line for everybody. Just so we could put them all on a new line. What am I showing you? The construction, how it actually propagates all the way through the API, right? So it doesn't matter what type of mail it is, it's gonna say everything that it is. So for example, number 3, M3 is the example here, right? M3, let's look for M3. Let me go to the main. M3. Let's look at M3. M3 is actually a regular envelope. So let's go to the API. It should say, I'm a male, I'm a regular male, I'm a regular envelope. See? I'm a male, I'm a regular male, I'm a regular envelope. Actually, since it's kind of tight on here, let me go up to the main class up here, and let's put it also here. I think we want to make sure we drop it down. Okay, you know what? Yeah, let's leave it there. So I am a male, I'm a regular male, I'm a regular envelope. That is going to be true for everybody. Like, let's say I change it to M4. You know what? Let's leave this one as M3 and this one as M4. So we could have 2 different ones. So the first one says, I'm a male, I'm a regular male, I'm a regular envelope. The second one says, I'm a male, I'm a priority male, I'm a priority box. See? So what did I do? I partially override the toString. I say, hey, do it like my parent, but add a little bit more. Do it like my parent, but add a little bit more. The idea is progressive. Progressive. We are a little bit better than our parents, and then our kids are a little bit better than us, and so the world is getting better. That's the whole idea, is that I can do what my parent can do, plus a little bit more. Now, obviously, just putting that little bit more gets me all this, because the construction says male, priority male, then priority box. That went like this. That went male, priority male. Let me just do that again. Male, priority male, priority box. That's the hierarchy. Boom, boom, boom. That's how it was made. Oh, what about object? Huh. Let's put that in. Object's a little weird. What it does is object actually puts down the address, the memory address. I'm going to put it here. Super that toString. I'll just put another new line as well. So this is going to print what the object where it's saved. Okay, it's going to look kind of weird. It's going to be like a hexadecimal number. So right here, see, I kind of separated them from the actual mail. So here's the objects toString. It's going to say, hey, it's a priority box and it's at this address. And this one says a regular envelope and it's at this address. This at 15dB is a hexadecimal number. So if I wanted to just do the objects, you'll see the name, the type of object it is, and its memory address. There's a code there. It's kind of encoding the memory address. So have this hexadecimal there. That is for the object. That's all the way up here. That's this guy. That is the toString that we saw here. If I click on it, it's going to tell you. It's going to say it returns a string representation of the object. In general, the toString method returns a string that textually represents this object. So it's kind of like a description. The result should be a concise but informative representation, so easy for a person to understand. So the stuff I'm showing you is you're putting the information, you're describing the object. The toString method for the object class returns a string representation of the name of the class for which the object is an instance, an @ sign, and an unsigned hexadecimal representation of the hash code of the object. Okay, and I think that hash code coming from the memory address or something like that. So basically, what we're saying here is, so let's go, we could actually look at the hash code. Where is it? So it says the method is supported for the benefit of hash tables such as provided by the hash map. The general contract hash code is whenever it's invoked on the same object more than once during an execution, hash code method consistently return the same integer. So this, I believe, comes from the address. So basically what you're seeing here is the objects toString. Okay, the objects toString in my mail class. That's from the API. And then everything else is my toString. This is all the information. So all a toString is all the information about the object. So if you go all the way down, you will see every piece of information. And again, just a little bit more. Call the parents toString, add on a little bit more. Now, let me just say one more thing about the object is that it has an equals method, okay? Now, when you see string dot equals and you see all those dot equals, that's this. It's kind of weird to do it last, but it's actually the last here. But the dot equals is a method that we should write for every object if you want to compare them, especially for equality. So it's normally done very early, so right here, the very first one, okay? So I'm going to do it right here. Public Boolean equals. All right, so they got to get the signature right. If I'm overwriting, the signature has to be right. Let's go back and check the signature. You see, you got to get object. Okay, this is the correct signature. I should actually do this. This is how you overwrite. You get the exact signature. Okay, a couple of things here. Sometimes I write object other because it's just the other object. So what do you mean other object? The other male. Okay, so the first thing you need to do is you need to convert these things to males and then get their weight, and then we need to know what type it is. So I'm saying it's going to be equal if it's the same type of male. Okay, so if it's the same type of male and the same weight. So let's do this. It's a bunch of if statements here now. So I'm going to first turn it into another type of male. Okay, so let's see, male other male is equal to male other. I have to do this first. It's always the first thing when you're writing an equal, because since I'm calling this with an object at the very top of my class, I shouldn't say class, at the top of my API, it could be any object. Like somebody could call this equals with a button and it should crash. I want it to crash right here because I don't want to compare button with a male. That doesn't make any sense. So I purposely want it to crash right here. It needs to be male compared with male. Now the next thing I need to figure out is what type of male is it? So I need the actual male, okay? So I have this male and the other male. So I need to know if the other male is an instance of a box, and this male is an instance of a box, and their weights are the same, then we're going to say that these things are equal. So let me do this first. I'm going to say Boolean same weight equal to this male that get me a weight is equal to other male get me a weight. So I got the same weight. Let me put the this first. Let me leave it here. It's fine. So I just created a Boolean variable. Let's say they're the same weight. Now I want to know if they're the same type. So I could say Boolean same type. I'm going to do a little Boolean algebra here. So it could be that this other male is an instance of a box. Okay, so we got, let's see, we got 4 options. It could be a regular box, regular envelope, right? So let's see, I'm going to put 2 or 2. Let's do envelope first. So this one could be other mail, this mail could be regular envelope. Oops, spelled it wrong. So if this mail is a instance of a regular envelope and the other mail let me kind of organize this. So I'm doing some Boolean algebra. So if both of them are regular envelope and they both have the same weight, so I'm going to return before I'm finished. Same weight. Same type. I'm not finished yet, so that's why I'm getting an error here. But once they have the same weight and the same type, then they're equal. Okay. So I want to do this again. I want to do it again. I think I'm going to do, I was going to do either one, but I'm going to just stick with the basics. So I'm going to say this is instance of a regular box. And this is also a box. And this one's going to be priority. And this one is going to be priority. So I have either they're both regular envelopes, they're both regular box, they're both priority. They're both priority envelope or they're both priority box. So either they're both regular envelopes, they're both regular box, they're both regular, priority envelope, or they're both priority boxes. They're the same type. So one of these things has to be true because an or. I'm mixing everything up here. So this is an and. If this is false, move on. The minute it becomes true, they're the same type. Short circuit. And then once I do that, I'm going to check to see are they both the same weight and the same type, then they're equal. Now, one other thing here is you should say, wait a minute, what about doing the equals here? Well, you don't have to because it inherits it. It's at the top. Everybody has the equals now. So I could compare any two males. If I have two males that are equal, it's going to return true. Okay, so because I have two males that are equal, they're going to turn true. Now, when I say they're both going to be equal, they have to be of the same type of male and the same weight. So I'm going to look here. And then I can see if I have any two males to compare. I have a regular envelope here, and I have a regular envelope here, M1 and M3, okay? So let's check this out. System.out.println is M1 dot equals to M3. Should say false. So how do you know it's false? Well, M1 and M3 are actually regular envelope. That's true. But they both don't have the same weight. Oh, let's see if we change it now. What if they're both 4 pounds? No, it's true. Obviously, the equals method and the toString methods, the two methods that the AP exam says to override, are very crucial. Even if they didn't say that, we'll have to, because this allows us to figure out which males are of the same type and the same weight. That's a huge deal, especially for sorting. I have one more piece to show that's not on the AP exam. That took it out. It's known as a comparable. A comparable. It's what the method is called compare to. Strings have it. A lot of API classes have it. So I'm going to stick that on here because it's not part of it, but it's actually nice to have. So that was the idea of multiple inheritance. I can implement comparable. Okay. Comparable what? Comparable males. What type are you comparing? I'm comparing males. Why? Because we need to sort them when we're doing working inside the mail room. So what's the method that we need to write? Now, if you realize something here, it's going to say, hey, something is wrong here. You're implementing comparable, but you don't have a method that's called compare to. So I am going to create that method compare to. Public int compare to. And we could put in a male here. The other male. It looks a lot like equals, okay? Now, if you realize just now when I didn't have the method, you see a lot of errors. Let me go ahead and take it out and show it to you. I'll put it back. See all these errors? See them? See everybody? Everybody saying, hey, you're saying we are comparable, but we don't have anywhere to compare ourselves. So I'm going to provide it. So how do we compare males? Well, the first thing is we could keep it simple. Since boxes are generally heavier than envelope, I was going to do something like this where I could separate them out and say, okay, I'm going to put the boxes on one way and put it. I'm just going to do a simple one here. I'm just going to compare them by weight. So if you are heavier, I'm going to consider you greater than. If you are lighter, I'm going to consider you less than. And if you are equal, I'm going to consider you the same in terms of sorting. So here's what we do. I'm putting a male here. We could have put object, other, and then cast it and do all that. But I'm going to put a male. That's fine too. So let's see. I'm going to compare these two males simply by their weights. Okay. So one way we could do it is we could just simply return the difference. Ooh. Can't spell. Return this dot get me a weight minus other dot get me a weight. That's it. This is how you actually write a compare to. The problem with this shows up a lot on the AP exam, is that this is a double and we're trying to return an int. That's a problem. So then how do you actually do this if this thing actually is a double? Very simple. I'm going to put double difference. I'm going to put this here. And then what you do is you use that difference to actually return. So I'm going to say if difference is 0, equal to 0.0. I'm going to return 0. You're wondering, why 0? Compare to sends back an int. Generally, they use 1, 0, and -1. 0 coming back means they're the same. If the difference is greater than 0, that would mean that this guy is heavier. So greater than returns a 1. And obviously, I'll return -1. Now strings use this, but strings do comparisons by lexicographical order, meaning if you're further down in the alphabet, you're greater. If you're earlier on, you're less. So if you compare two strings and you're looking for them lexicographically, it's going to do them in alphabetical order, especially if they're words, not including weird characters. But if they're just regular words, they'll do alphabetical order. This is the same thing. It's in the string API. I'm writing this because I need to take, so for example, you'll take the first string and the second string, and you'll figure out their ASCII, and you'll subtract, and then you'll figure out which one's greater, and so on. So very common. It's not in the AP exam, but it's a huge thing. Why do I do that? I gotta show it to you. Ready? Watch this. Arrays dot sort. Actually, let me undo that because he likes to do that for put in this thing. Arrays dot sort. Sort what? Males. Oh, which males? This array. Import it. It's in the util package. Huge. Big deal. Big deal. Because the post office definitely want to sort their mails. Now, I could sort things many ways, okay? I just did weight here. Okay. I did just the weight for the sorting category, characteristic or type of sorting. But we could sort this based on the address. We could sort this based on, we could do a lot more here, but I'm just showing you the weight. So right now, if this thing is sorted, when I print it, it's going to be in a sorted fashion. Now, obviously, I'm not going to go through and check to see if it's sorted, but it is. Oh, last thing. What if it was an array list? Good one. That's the one here. An array list of male. Call it male list. New array list of male. Empty. So I'm going to add some males to this. Okay, let me just import this from the util package. I'm going to say, hey, male list. Why don't you add M1? Oh, I'm going to just add all of them. M2, M3, putting it all together here. M4. And then I'm going to print. You know what's good about this? The male list is going to print the toString. Let's run this. Watch this. Let's see how nice this is. Wait a minute. Where is it? Trying to find it somewhere. I think it's right here. Here it is. Hold on, let me see. Don't see where it starts, but I've seen it. Oh, here we go. So see that right there? The little bracket, that's the start of the list. Remember, I print them vertically, so you can see the comma, next one, comma, next one, and then somewhere down here is the ending bracket right here. So that's this list. But then, what about if I was to sort this list? Collections dot sort. This is powerful. Male list. I got to actually import it. Forgot to spell collections wrong. Let me import it. Come on, be kind. Here we go. It's in the util. Almost all sorting and stuff like that in the util. See? Boom. Boom. If whether I made a list of males or an array of males, I can sort them. Why? They're comparable. See, this comparable has one method. That's all an interface is. It provides behavior, forced behavior, just like this. Yes, it's abstract. And I'm overriding it. That's a lot. That's a lot. Way more than the AP expects. But Because it's abstract and because it says I need to do it, how do I say it needs to do it? I implemented it. This is forced. Now, because it's all the way at the top, all of them doing it. Everybody is now comparable, so I could compare them, which means I can sort them. And let's look up arrays.sort. What type of sorting is this? What type of sorting is this? Let's go look it up. Arrays.sort. Look at this. Binary search. Binary search. Overloaded. Overloaded. Let me go looking for copy of. Overloaded. A lot of overloaded methods. I'm going to look for sort. It's in alphabetical order, so it's S. Where is it? There we go. It's overloaded too, so I could pick anyone. Let me just do this. See? Quick sort. It uses quick sort. Quick sort is a more improved version of merge sort. That's what's in the API. Backing up. Let's wrap it all up. It's all the end here. Unit 9, object oriented. We have an API, we built it. We have all the specs, we included every spec. We added extra. We added some extra. Remember how polymorphism works. What we're seeing here. Also remember overloading versus overriding. Overriding is when the signature is the same. Overloading, the signature is different. Not just the return type or the name of the dummy variables. That don't work. It has to be the type of variables in the parameter list by number and type. Order as well. So we got to make sure we're paying attention to that to see if a method is properly overloaded. Now, once we went a little bit more and we did the equals and the compare to, we override the toString, we override the equals from the object, then we override the toString all the way through the API. We didn't do this one because it's the same no matter where. We could actually override this as well. Then we implement the comparable interface to compare. Once we compare, we can sort, we can print, we can do all this good stuff with the API. This is not an app, okay? This is just an API, and I'm showing you how it works. That brings us to the end of the entire Unit 9.